Alright, this is Mr. Martin. In this video we're going to continue graphing polar equations. So for this example we're going to look at r is equal to 1 minus 2 cosine theta. And you may recognize from the previous videos that this is going to be a limosone. So let's go ahead and start graphing it. So identify the type of polar equation. So this is in the form r is equal to a minus b cosine theta, which like I mentioned is a limosone. And let's look at the ratio of a to b. So a over b is a half. So that means that we're going to have an inner loop. Alright, and also since b is less than 0, it means that the majority of this is going to be left of theta equals pi over 2. So if we're starting to think of what this is going to look like, we have an idea based on what the shape of a limosone looks like and how this one's going to have an inner loop, and since b is negative, it's going to look something like this. Alright, so hopefully after we graph this we'll get a shape that looks something like this. This point here should be at the origin there. Alright, so again, let's do our test for symmetry. Again, if we do our tests correctly, this should only have polar axis symmetry. So we're going to replace r comma theta with r comma negative theta. So r is equal to 1 minus 2 cosine negative theta. And we know that the cosine of negative theta is the same as the cosine of positive theta. So we get r is 1 minus 2 cosine theta. That's our even-odd identities. So this one works. And let's check for our other symmetries. R is equal to 1 minus 2 cosine. We're going to replace this with pi alright, so it's going to be 1 minus 2. We've got to use our difference formula, so we're going to have cosine pi cosine theta plus sine pi sine theta. Again, we're just using our difference formula for cosine to get all this. And sine of pi is 0, so this whole term here is 0. And the cosine of pi is negative 1. So this becomes 1 minus 2 times negative cosine theta, which is equal to 1 plus 2 cosine theta, which is not equivalent to the original one, so this one does not work. And the last one, checking with respect to the pole, we've got r is equal to 1 minus 2. We'll replace it with pi plus theta. And again, we're going to use our sum formula for cosine. So we have cosine pi cosine theta minus sine pi sine theta. Again, sine of pi is 0, so this whole thing is 0. Cosine of pi is negative 1. So this becomes 1 plus 2 cosine theta again. So it fails the test for symmetry with respect to the pole. Alright, which these turned out the way they should have based on what we know the shape of a limosone looks like. Alright, now, since it has symmetry with respect to the polar axis, if we just graph values from 0 to pi, whatever values we get for those, we can just reflect it over the polar axis to get the other values. So, and again, if you have a non-graphing calculator, you'll be able to use that. Otherwise, I'm going to give you some of the more common decimal values for roots. So let's look at 0. And if I plug in 0, I'm going to have 1 minus 2 cosine of 0. So the cosine of 0 is 1. So I'm going to get 1 minus 2 times 1. So that's 1 minus 2 is negative 1. So my r theta here is negative 1. And we're going to rotate 0. So let's go ahead and put that on here. So that's going to be right there. Alright, and then let's go every pi over 6. Sometimes we may need to fill in with pi over 12s, but we'll go to pi over 6. So it's 1 minus 2 cosine pi over 6. So that's going to be 1 minus pi over 6 is root 3 over 2, the cosine, and then multiplied by 2, so that's root 3. So that's 1 minus root 3, which is approximately negative 0.73. So I'm going to go about negative 3/4. And then I'm going to rotate pi over 6. So that's going to put me right about there. I'll give you some bigger graphs than this. This graph doesn't need to have so many circles on it, but we'll make it work for this. Now, since we have symmetry with respect to the polar axis, I'm going to take this point and I'm going to reflect it over to there as well. So it's going to be right over there as well. Alright, next let's calculate for pi over 4. So we have 1 minus 2 cosine pi over 4. The cosine of pi over 4 is root 2 over 2 times 2 is root 2. So that's going to be 1 minus root 2, which is approximately negative 0.41. So negative 0.41, and then we're going to rotate pi over 4. So it's going to be right about here. And then again, we're going to reflect that over to there. So we can see we're getting our loop. So there's those 2 points. So this point here was negative 0.73 comma pi over 6, and this one was negative and pi over 4. Alright, next let's do pi over 3. So I have 1 minus 2 cosine pi over 3. Cosine of pi over 3 is a half times 2 is 1, so 1 minus 1 is 0. So this point is 0, pi over 3. So that's just a point at the origin. And next we've got pi over 2. So 1 minus 2 cosine pi over 2. Cosine of pi over 2 is 0. So it's going to be 1 minus 0, which is 1. So I have 1 pi over 2. So 1 pi over 2, and then we'll reflect that over the polar axis as well. Alright, and then 2 pi over 3. Just to expedite this a little bit, if you want to pause the video and work these out, feel free. And then we'll have 3 pi over 4, 6, and then pi. So if we calculate these out for 2 pi over 3, we should get 2 comma 2 pi over 3. So we're going to go 2 and rotate 2 pi over 3, that over the polar axis. And then for 3 pi over 4, that should come out to about 2.41. 3 pi over 4. So let's graph that. So here's 2 and 3, and then we're going to rotate 3 pi over 4. So 1, 2, 3, and then just a smidge under a half. And then we'll graph the same point below. So that's going to be about there. And we're getting close, 2 more. So for 5 pi over 6, it comes out to about 2.73. 5 pi over 6. And for pi, it's going to be 3. So 3 comma pi. So 2.73. So it's going to be a little closer to 3. And then we're going to rotate 5 pi over 6, so it's going to be about there. And then we'll reflect it. And then the last one here is at 3 comma pi. And if we connect this all, we should get our limsone, which looks something like that. So not too bad. All right. So again, as always, if you have questions, make sure you ask. And we'll see you in the next video where we'll look at another example of graphing a polar equation.